opposite sides of a parallelogram are congruent. So to start off, I drew a parallelogram ABCD that shows that parallel opposite lines are parallel. So line AB is parallel to DC and BC is parallel to AD. So to start off this proof, we have to divide this parallelogram with a line, making it into true right triangles, like this. And because these lines are parallel, we could conclude that this line could be a transversal. So how do we start off? Let's start off using these two parallel lines. And if you automatically see, you can see that angle ABD is congruent to angle BDC because of alternate interior angles. Now, if you shift it like that and you use these two parallel lines, you could also see that angle ADB is congruent to angle DBC. Now, what you have here, you can conclude that these two right triangles that make these parallelograms are congruent to each other because of angle side angle, because this angle, and this side, which is the same, thus it is congruent, and this angle are the same. So we're stating that triangle ABD, one over here, and triangle is congruent with triangle BC. Now, to prove that opposite sides are congruent, we can use the area that both corresponding sides and corresponding angles of each triangle that is congruent are congruent. So we can say that this line of this triangle DC is congruent to this line of this triangle AB because they're correspondent, and the same with this and this. Therefore, we can conclude that this theorem is proved. Opposite angles of a parallelogram are congruent. So now we also have a parallelogram here, and here we have to prove that CAB is congruent to BDC, and that angle ABD is congruent to angle DCA because they're opposite angles. So we have to prove that they are congruent. So here in this parallelogram, if we look at it closely, we can see that it's made full of transversals and of parallel lines. So if we extend them, so here, after we extend them, we can see that we can use any as a transversal and as parallels to prove that these angles are congruent. So, first, we have to prove that angle CDB, this one over here, is congruent to angle EBD over. So, how are we going to do this? First, if we get this line, BD, to be the transversal and these lines to be the parallel lines, we can prove that this angle over here, which is angle CDB, is congruent to this angle over here. Let's put this one as E. So we can prove that this angle EBD is congruent to angle CDB because of alternate interior angles, because they're alternate interior. Now, let's change it a little bit. Let's change the transversal. And let's change it that it's the transversal AB. Now, we can see that this angle over here, angle EBD, is congruent to angle, let's put this F. We can prove it is congruent to angle BAC or CAB due to the fact of corresponding angles. If this is the transversal, these are parallel lines. These two are corresponding angles. Now, if we know that EBD is congruent to angle BAC and that angle BDC is congruent to angle EBD, we can think that this angle over here is congruent to this one. So we now know that these opposite angles are congruent. Now, if we do the same with the other two, we can also know that those two are congruent. This angle is congruent to this angle, we can conclude that this angle is congruent to this angle, which are also opposite angles. So now we can prove that opposite angles are congruent in a parallelogram. Diagonals are parallelograms that bisect each other. Okay, so firstly we need a parallelogram, which I already drew, A, B, C, D, which the diagonals, which we're going to prove that bisect each other, and the midpoint E. And because these lines are parallel to each other in a parallelogram, then they are parallel. Okay. So as we can see, these lines are not only diagonals, but they can also be used as transversals. So automatically we can see that angle ABE, angle ABE here is congruent to angle CDE over here because of alternate interior angles. So if we change our transversal to this one, we can also see that angle BAD is congruent to angle DEC over here. DEC. So because opposite sides of a parallelogram, as I proved it 2 videos ago, are also congruent, then we can say that side AB is congruent to side DC. Yes, so this is congruent. So now, if we take a look to these 2 triangles, ABE and triangle CDE, they are congruent because of angle side angle, because this angle is congruent, this angle is congruent, this side is congruent, this side is congruent, and this angle is congruent, and this angle is congruent. Thus, these 2 angles are congruent. Now, so we can say that AE is congruent to EC because each corresponding of our congruent triangle corresponding sides are also congruent. So we can say this. So this is congruent to this. And we can also say the same thing with BE and ED because they're also part of the triangle. This is congruent to this. So as you can see, this is congruent to this and this is congruent to this because they're corresponding in the congruent triangles. So now we can conclude that the line DB, the diagonal DB, is splitting the diagonal AC into 2 equal segments of equal length because this is congruent to this, so they are equal lengths. And we can say it backwards as well, that AC is splitting DB into 2 lines of equal length because they are congruent. Thus, we can say that these 2 diagonals are bisecting each other.